Welcome back guys to the channel. Today we're going to be talking about logs, indices and functions, and we're going to be using examples from the exam papers. So the example for today, we're going to be looking at the 2020 Maths paper 1 higher level question 3. So here's the question. Part A, you have f of x equals 6x minus 5 and g of x equals x plus 5 over 6. They want you to investigate if f of g of x is the same as g of f of x, and they want you to write the conclusion. Part B of the question, the real variables y and x are related by y equals 5x squared. The equation y equals 5x squared can be written in the form log 5y equals a plus b log 5x. Find the values of a and b. So pretty much they're asking you to turn the indices y equals 5x squared into logs, the log 5y equals etc. And then part 2 of part B, it's saying hence or otherwise find the real values of y for which log 5y equals 2 plus log 5 126 over 25x minus 1. So we start with part A. We're trying to investigate if f of g of x is the same as g of f of x. So there is f of x, there is g of x. Let's start with an example, a simple one. So if the question was find f of 2 instead of f of g of x, you'd just sub in 2 into f of x. So whenever you see x, you would put 2. So you end up with 6 bracket 2 minus 5. If you do that calculation, you end up with f of 2 equals 7. So you have to do exactly the same thing, but instead of subbing in 2, we're going to sub in g of x when we see x. So f of g of x is going to be 6 bracket x plus 5 over 6 minus 5. And then we're just going to simplify that using algebra. So the 6's will cancel, you'll be left with x plus 5 minus 5, which will just give you x. So f of g of x equals x. So that's half part of that question done. Now we have to do g of f of x and see what that gives us. Are they the same? So g of f of x, we do the same thing. Whenever we see x in the g of x equation, we put in f of x, which is 6x minus 5. So we put 6x minus 5 plus 5 over 6. The plus 5 and the minus 5 will cancel on the top, and you're left with 6x over 6. The 6 on the top and the 6 on the bottom will cancel, you're left with x. So g of f of x is equal to x. So they are the same. G of f of x and f of g of x are the same. So the conclusion, you would have to write that at the bottom to get full marks. So you would conclude that f of g of x is equal to g of f of x. And that's part A done. Part B, you have the real variables y and x are related by y equals 5x squared. The equation y equals 5x squared can be written in log form. They want you to find, if you write it in that form, they want you to find what's a and what's b. So the goal really here is to translate the indices into logs. And that's the whole question here. Right, so this is the general way of how you would translate an index to log. So that's how it looks like. And what are the steps? So you label them, these numbers 1 and this one you label 3, and then this one you label 2. So this is the order in which you would put them in the log format. So the one you labeled 1, that's the one that comes first. So if you look at here, the one that I labeled 1, that's the little number, that's the first number that goes in the log form. The one that I labeled 2 will be the second number, so the C, and the one that I labeled 3 will be the last number. So that's how I turn that into logs. So that's the general way to do that. So we're going to try to do that for hours. This is our question. It has indices. How do you know it's indices? It has a power there, right? So it's an indices and it has a power, and technically everything is an index because anything can be put to the power of 1 and it remains the same. So you can turn anything to logs. So in this case, we kind of don't rush here. We kind of look at the question and try to match our answer, to tailor our answer to the question. So here we clearly see that our question should have log 5. So that means our little number in the a, in this case, the a on the top example, our little number should be the 5. So the 5 should be the one with the power, right? If you look at it, the first number is the one that is put to the power of something equals something. So that means our 5 should be the first number in the indices. So we have to rewrite that y equals 5x squared. We have to rewrite it. So we rewrite it like this, where we have 5 to the power of 1, which is just 5, equals y over x squared. So if you write it this way, then we can have a log 5. So now if you write it this way and we follow our example of 1, 3, 2, this is number 1, this is number 3, and this fraction, the y over x squared, is number 2. So the 1 is number 3. So we just put it into logs. It will look like this. You have log number 1, it's 5. Number 2, it's y over x squared. And then number 3 is 1. So that's how we turn it into logs. So it looks good, but still does not look exactly like what we have. So it's in logs. If the question was just turn it into logs, the question is done. But they want you to turn it into logs, but in that form. So we still have some simplification to do. So we remember a law of logs that tells us if you have a fraction there in the middle there, the y over x squared, you can split it into 2 logs, because clearly there we need to have 2 logs. We have log 5y and then we have b log 5x. So we need somehow to turn that into 2 logs. So we can do that using this. So this law tells us that it will be log a of the thing on the top, which is c, minus log a, so the base is the same, log a, and then the thing on the bottom, d. So we do the same thing to our question. We end up with log 5y minus, because they're being divided, log 5x squared equals 1. Again, we now have 2 logs, but we're still not there yet. If you look at our question, you're always comparing your answer to the question until, if you're trying to prove something, you're always doing that check. Are you there yet? So right now we're almost there. We have the 2 logs, the log 5 and the log 5, but still the order is still different. So we still have to deal with that, and there's no x squared, so we have to get rid of that. There's only b log 5x. So we remember another law of logs that tells us that if you have log a b to the power of k, you can rewrite that as k log ab. So the k, the power, you can move it to the front, or you can move it to back to the power again. You can go back and forth. So that arrow is representing that. You can take the k in front of a log and you can put it as a power, or you can do the reverse. You can take the power and put it in front. In this case, we want the reverse. We want the k to be in front. So in this case, our k is the 2 in front of the x squared. So we can rewrite that as log 5y minus, we take the x squared, the squared on the x, we put the 2 in front of the log. So it becomes log 5y minus 2 log 5x equals 1. Again, it's almost there. We have the 2 logs, we don't have the x squared anymore. It's looking good. The last step is just to rearrange it so that it looks exactly like that. The question there is log 5y is on the left, and then the rest is on the right. So we have to do that. If we start comparing these two now, our answer will be wrong because they're not in the same order. So we have to make sure the order is the same, exactly the same as the question. So if you rearrange the order, now it looks exactly as the question. You have log 5y equals some number a, in this case our a is equal to 1, and a b in front of a log 5x, so our b is 2 in front of log 5x. So now we can confidently say a is 1 and b is 2. And that's the end of that part of the question. So part 2 of the question, it's saying, hence or otherwise, find the real values of y for which log 5y equals 2 plus log 5, 126 over 25 x minus 1. So they said hence, so that means we're going to use the information we got from the previous part of the question. So what have we got? We know that this equation and we know this equation. So we're going to use that to try to solve that. So solving for y here, you have an equation that has 2 variables. It has x and y in it. You cannot directly solve it alone. So one way is to get rid of one of the other letters and find the other letter. So make the equation just one letter, right? So we're going to take this equation that we have. Instead of saying log 5y, we're going to get rid of the y, and then we're going to try to get x. So we substitute that for log 5y. We know what log 5y is equal to. We take that in, we put it there, and then it becomes like this. So that's our equation now. So we solve for x, we find the value of x, and then we put it back into the other equation there on the top that is saying y equals 5x squared. So when we know x, we put the x there, and then we get the value for y. Right. So let's do that. Here the goal is you want to get all the logs to one side and then make them into one log, and you want to get all the numbers like the 2 and the 1 together as well, right? So you want to simplify it. So if you do that, you move the log 5 bracket 126 over 25x minus 1 to the left, or you take it away from either side, you end up with that. And then if you move the 1 on the left to the right, it becomes minus, so you end up with 2 minus 1 on the right. And then we can use this law of log, right? We want to add those two logs, the 2 log 5x minus log 5 126 over 25x minus 1. We want to put them into one log. They have the same base, the 5, so we can put them into one log. But first, we have to get rid of the 2 in front of the log 5x. And we use this law of logs we already used, but we're using it in reverse, where we can, instead of making a power, we want to get rid of, instead of getting rid of the power, we want to make the power. So in this case, we have 2 log 5x, so we want to make it, we want to remove the 2, so it becomes a power. So it will become log 5x squared. So we move the 2 there, and then it becomes log 5x squared minus log 5 126 over 25x minus 1 equals 1. Right, so the 1 is coming from 2 minus 1 on the right. So now another law of log that we can use, we want to make those two logs into one log, so they're taken away from each other. You have a law of logs that you can use. By the way, all these laws of logs are in the log tables. The law tells you that if you have two logs on the right, you can make them into one by making a fraction if they're taking away from each other. So which is the case here. So it will be log A, the first one, which is C, over D, the second log. So in our case, it will be log 5. The first one is x squared, and the second one is the 126 over 25x minus 1. So 126 over 25, just to simplify it for visual purposes, just put that in the calculator, you get 5.04. Instead of writing the 126 over 25, it would look awkward to have a fraction on the bottom again of a fraction. So you can just make that decimal if that helps. Equals 1. So now the goal is we have one log and one number on the other side. We can solve it. We have to turn that log into indices. So we have to do the reverse of what we did in the other part of the question, part A. So we use the same strategy again. We label the log 1, 3, 2. So we put those numbers in the index form in that order. So the first number is A, the second number will be B, so A to the power of B, the third number will be C, equals C. So it's the same strategy to turn the log into indices. It's the same way we would have turned the indices into log. So just label them 1, 3, 2, and then put them in the order that you have written, like 1, and then number 2, you put it on the number 2 position, and number 3, put it on the 3rd position. So if you do that, our 1 in this case is 5, our 2 is 1, so 5 to the power of 1, and our 3 is the middle number, the x squared over 5.04x minus 1. So when we do that, you can then solve that equation. It's now an algebraic equation. 5 to the power of 1 is just 5. So you end up with this equation. So you can multiply both sides to get rid of the fraction by 5.04x minus 1. And then on the right, you're just left with the x squared. So if you multiply that out, you end up with 25.2x minus 5 equals x squared. And then you realize it's a quadratic. So if it's the quadratic, you want to use the quadratic formula to solve it. So to use the quadratic formula, everything has to be on one side first before you choose your A, B, C to put in the formula. So you put everything to one side. So it becomes x squared minus 25.2x plus 5. And then you have the B formula, which is in the log tables. You put in the terms A, the number in front of behind x squared, it's 1 in this case. And then your B, it's minus 25.2. Your C, it's minus 5. You put that in, and then you get two values of x, as you always do. You always get two values when you use this, plus or minus formula. So you end up with x equals 0.2 and x equals 25. And then the last step is to just get this equation from earlier and then find y. Remember, the goal was to find y in this case. So you'd substitute that in one value at a time to get your value for y. So if I sub in the 0.2, I get y is equal to 0.2. If I sub in the 25, I get y equals 3,125. And that is the two answers. So they say the answer, or otherwise find their real values. So that's a hint that there's going to be two values, and we have them, 0.2 and 3,125. And that's the end of the question. Thank you for watching. Please subscribe and share with your class.